If you look at nature, there are numbers all around us. You know, look at the flowers, for example. So there are many flowers that have three petals like this, or five like this. Some of them may have 34 or 55. These numbers occur very often. These may sound like random numbers, but they are all part of what is known as the Fibonacci sequence. Around 1200 AD, in Pisano, Leonardo Pisa published the Liber Abazi, or Book of Calculation. It is an arithmetic text which concentrated mainly on financial computations and promoted the use of Indo-Arabic numerals, the forerunner of today's familiar system, which uses just 10 digits, 0 to 9, to represent all possible numbers. This number sequence was developed in Middle Ages and it was named after Leonardo Pisano Biglio, a famous Italian mathematician who also happened to discover Fibonacci. Fibonacci sequence is an integer in the infinite sequence 0, 1, 1, 2, 3, 5, 8, 13, so on. A sequence is an ordered set of numbers, shapes, or in any other mathematical objects arranged into a rule.
The Fibonacci discovery of the Fibonacci sequence happened to approach the ratio asymptotically. The Fibonacci sequence is a series of numbers in which each number, Fibonacci number, is the sum of the two preceding numbers. The simplest is series 1, 1, 2, 3, 5, 8. He found the interesting and mysterious properties of the Fibonacci sequence that the series has a deep relationship with the golden ratio. The golden ratio was first called the divine proportion in the early 1500s in Leonardo da Vinci's work, which was explored by Luca Pacioli, Italian mathematician, entitled De Divina Proportion in 1509. This contains the drawings of the five Platonic solids, and it was probably da Vinci who first called it the section aurea, which is Latin for the golden section. What do the pyramids of Giza and da Vinci's Mona Lisa have in common with Twitter and Pepsi? Quick answer: they are all designed using the golden ratio. The golden ratio is a mathematical ratio. It is commonly found in nature, and when used in design, it fosters organic and natural-looking compositions that are aesthetically pleasing to the eye. But what exactly is the golden ratio? Putting it as simply as we can, the golden ratio, also known as the golden section, golden mean, divine proportion, or Greek letter phi, exists when a line is divided into two parts, and the longer part, A divided by the smaller part B, is equal to the sum of A plus B divided by A, which both equal 1.618. It appears many times in geometry, art, architecture, and other areas.
The actual value of the golden ratio is equal to 1.6180339887498948820 and so on. The digits just keep on going with no pattern. In fact, the golden ratio is known to be an irrational number because, as we saw before, that the golden ratio can be defined in terms of itself. Like this, phi is equals to 1 plus 1 over phi, or in numbers, 1.61803 is equals to 1 plus 1 over 1.61803. That can be expanded into this fraction that goes on forever, called a continued fraction. Phi is equals to 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 and so on. So, it neatly slips in between simple fractions. But don't let all the math get you down. In design, the golden ratio boils down to aesthetics, creating and appreciating a sense of beauty through harmony and proportion. When applied to design, the golden ratio provides a sense of artistry, an X factor, a certain je ne sais quoi. Our bodies and faces even follow the mathematical ratio.
The golden ratio can be applied to shapes too. Take a square and multiply one side by 1.618 and you get a rectangle of harmonious proportions. Now, if you lay the square over the rectangle, the two shapes will give you the golden ratio. If you keep applying the golden ratio formula to the new rectangle on the far right of the image above, you will eventually get this diagram with progressively smaller squares.
Whoa, need a break? Hold on, just a few mind bogglers to go. If you take our golden ratio diagram above and draw an arc in each square from one corner to the opposite corner, you will draw the first curve of the golden spiral or Fibonacci sequence. You'll find this beautiful creature throughout nature's forms. Ferns, flowers, seashells, even hurricanes. Which perhaps why we find it so visually appealing. Because it is, indeed, nature at its finest.
And that brings us to the end of our presentation. Let us now recapitulate the essential key points we have discussed. First is Lesson 1, Patterns and Numbers in Nature and in the World. We have learned that the natural world is full of beauty and amazing shapes and patterns. Just like the patterns we see in snowflake and honeycombs, tiger stripes and hyena spots, the sunflower, the snail shell, flower petals, the world's population, and in the weather.
And in lesson number 2, the Fibonacci sequence. We have learned in this lesson that Pisano or Leonardo of Pisa is the one who discovered the Fibonacci. We also learned that the Fibonacci sequence is a series of numbers in which each number, Fibonacci number, is the sum of the two preceding numbers. And lastly, we also learned that golden ratio also boils down to aesthetics, creating and appreciating a sense of beauty through harmony and proportion.
Before we say goodbye, let me say this to all of you. We may have some idea as to how all this in our world works, but not the complete answer. In the end, it remains the great math mystery.